You are welcome back to the channel. My name is Daniel, and in today's video we have an exercise on the board under conditional probability. So this will be our first exercise under conditional probability. We are going to do a couple of questions, a series of them, and will drop each of these questions in the same playlist. So if you look at this exercise very well, it is saying that an automobile company has three assembling plants: Abu Dhabi, Dubai, and Doha, which contributes 35%, 40%, and 25% total output, okay, respectively. Then he said that the following percentage of defective vehicles have been observed from the various units. Abu Dhabi produced 3%, Dubai 2%, and Doha 4%. Then it says if there is a quality control check before outputs are exported, calculate the probability that an SUV found defective at this stage originated from A. Abu Dhabi, B. Dubai, and C. Doha. So this is very simple, but before you tackle this, if this is your first video, I would advise you to go through the series of introduction I have placed there. We have part 1, 2, 3, and 4. They are series I've explained the formulas into details and proven most of them for you to understand. Okay, so let's box on to what we have today. So to solve this, the first thing that we will do is to put down our data. Okay, so our solution becomes, we say that let plant Abu Dhabi, the first one, be equal to what? A. Okay, then let plant B be equal to Dubai and plant C be equal to Doha. Now that we've been able to represent the various plants with these variables, the next thing we'll do is to draw a diagram, okay, to explain whatever we have here. So we'll draw a diagram and then indicate the defective that happened for all the three plants. Now from this diagram, we will divide this into three because we have three plants. So we have plant 1, plant 2, and plant 3. So let this side be A, this be B, and this be C. Their intersection, let's circle their intersection, and let's make this place D, okay? Where the D we have here equals the defectives. Now the next thing you should do is to draw a tree diagram and indicate your data on the tree diagram to make it simple for us, okay? Even though we've not been asked to do that, we have to do it. So I will draw my tree diagram. Let's assume that this is the tree and this is my branch 1. This is branch 2 and this is branch 3, okay? So I'll label this branch plant A, this plant B, this plant C. Now when we go back to the question, he said that the output generated by the three plants was what? 35%, 40, and 25%. That means when plant A was generating or producing the vehicles, it has a total output of what? 35%, including the defectives, okay? Because it generated some amount of defective. So that is the probability of A. So probability of A gave us 35%. When you divide this by 100, you have 7 out of 20. Then probability of B gave us 40%. This is giving us 2 out of 5. Then probability of C gave us 25%, which is equal to 1 out of what? 4. The next thing we will do is to look at the defectives. Now he said the defectives from the various units was found to be 3%, 2%, and 4% respectively, okay? When you look at this, this means that when plant A was producing the SUVs or the vehicles, it has a defective of what? 3%. It means that defective D as A has occurred, where A stands for what? Plant Abu Dhabi. So this is where you put it. So let's assume we put it here. So that is the probability of the defective as A occurred, meaning that defective probability of defective coming out from plant A gave us what? 3%. So we have 3 divided by 100. Then for B, we have 2%. So the probability of the defective given B gave us 2%, which is 1 out of 50. Then the probability of what? The defective as C occurred gave us what? 4%, which is the same as 1 out of 25. Now let's move on to the question itself. The question said calculate the probability that an SUV found defective originated from any of these three plants. Now, because we have three plants, we know that plant A generated a certain amount of defective, B and then C. But we want to find their probability and know which one of them generated the highest defective. Okay, and that plant will be the one we are looking for. Do you understand now? And to be able to do that, then we need to look for D, the intersection between A, B, and what? C. To be able to do that, we need the defective generated by plant A, the one produced by plant B, and the one produced by plant C. Once we get that, we will sum up the result to get the defective capital D generated by all the three plants. And that D is going to help us. The D stands for the defective. Is going to help us to solve the question. So now we are going to find the probability that a randomly selected plant here is defective. So from here, we are looking for the probability of what? D. So probability of D here is going to give us the probability of A intersection D, the event A and D occurring together, because when the plant was producing the SUVs, the defective and the good product all happened together. Okay, everything happened together. So now we will say that A intersection D is telling us that event A and D occurred together. Okay, occurring union. Then we go to plant B, this and D happening. So that is giving us probability of what? B intersection D union probability of C intersection D. The union here means what? Addition. Now watch something. Let us consider the event A and D occurring together. If we consider that and we want to find that, then we need to go to event A on the tree diagram. Now look at this. We need the probability of D. That was generated by plant what? A. So D, when A occurred, when plant A was producing the effect, what was the probability of D? Do you get it now? Or D produced by what? A. So the probability of what? D as A occurred is going to give us the probability of A and D occurring together, A intersection D, divided by the probability of the event A. We are conditioning on this. We know that this event has already happened. Okay, so this is what? A. Do you understand now? Now, when we divide here by 1 and we cross multiply, what happens? P of A intersection D will be the product of probability of A and its conditional probability. And that becomes P A intersection D is going to give us probability of A times the probability of what? D as A has occurred. So now whatever we are seeing here, we are going to replace it with this. We will do the same thing for plant B and the same thing for what? Plant C. A intersection D is going to give us the probability of A times the one I just wrote here. So we have the probability of what? D as A has occurred. Union means we are adding, plus the probability of what? B. We are doing the same thing here, times its conditional probability. D as B has occurred, plus the probability of C times its conditional probability, P of D as C has occurred. We can say that probability of A gave us 7 out of 20 times its conditional probability is 3 over 100, plus we go to probability of B, which gave us 2 over 5, times its conditional probability 1 out of 50, plus then the probability of C is what? We are getting 1 out of 4 times its conditional probability 1 out of 25. Okay, punch this on your calculator. When you punch this, you are getting 0.0105 plus 0.008 plus, when we punch this, we are getting 0.01. Okay, now when we sum up this result, then we are getting the probability of D, the intersection we have here, to be equal to 57 divided by 2000. Okay, this is the same as 0.0285. Now that we've been able to find the probability of D, we can now calculate for which of these plants is likely to have produced the defective, the highest defective. So how are we going to do that? What it means is we are looking for the probability of the event A given D. This time we are going to condition on the D. We assume that the event D has already occurred. The defective has occurred. Now we need to find the probability of A, the probability of B, and the probability of C, and find out which one of the defectives from the three plants was the highest. Do you understand now? So that is what we are going to do. So to determine which plant is likely to have produced the defective, we are looking for the highest defective. Put that in mind. We need to find the probability of A given D, B given D, and C given D. Do you understand? So now we are going to condition on the D, like I said earlier. So we will find the probability of plant A given that D has occurred. Okay, so this is going to give us the probability of A intersection D. We are writing the formula divided by the probability of what we are conditioning on D. So we will divide by D. We are conditioning means we are assuming that the D has already occurred, which is here. So now this becomes, now we already know A intersection D or D intersection A, which is here. So we just substitute that value. So we have 0.0105. You divide this by the probability of D, which is 0.0285. So probability of A as D has occurred is giving us 7 out of 19, which is the same as 0.368. Let us find for plant B. So probability of plant B, given that D has occurred, is going to give us P of B intersection D out of probability of what? D. When we do this, we know the event B and D occurring together, which is 0.008. So 0.008 dividing 0.0285. So probability of B as D has occurred is giving us 16 over 57, which is the same as 0.281. Okay, now the last one is the probability of C, and to do that we have our P of plant C as D occurred, giving us the probability of C intersection D divided by probability of what? D, meaning C and D occurring together was 0.01. You divide this by 0.0285. Okay, then this is giving us P of C as D has occurred is giving us 20 divided by 57. Now when we change this to decimal, we have 0.351. I've rounded this into 3 decimal places. So now that we've been able to find the probability for all the 3 plants, what are we supposed to do? We need to compare the values and find out which one of these machines produce the highest defective. And to locate that, we need to look at the values. That is why I changed them to decimal numbers. When you look at this, we have 0.351. When we look at this, we had 0.281. And finally, we had 0.368 for this plant. So which one of these is the highest defective? It is clear that plant A generated the highest defective. Okay, so what does that mean? So what this means is that, listen very carefully. Given that a product is defective D, the probability that it came from plant A is 0.368. When we multiply this value 0.368 by 100, what do we get? We are getting what? 36.8%. Do you understand? So given that a product is defective D or an SUV is defective D, the probability that it came from the plant A is 36.8%. The probability that it came from plant B gave us what? 28.1%. The probability that it came from plant C gave us what? 35.1%. So this is the highest value. So you can rewrite this. So you can write this for the examiner that the plant that is likely to have produced the defective is plant what? A, which is the same as plant Abu Dhabi. I hope I've been able to explain this for you to understand. Okay, so I will take series of exercises under this same thing or this same topic and drop it on the page for you to really get the concept. So we are going to do different kinds of exercises, and these will help you and equip you. My name is Dan, and I will see you in the next one.